I'll be making a quick video on how to use Nixtla's NeuralForecast model. So Nixtla's NeuralForecast, which you can access by copying this URL and pasting it somewhere in your browser, or just manually typing it in, is a collection of neural forecasting models focused on their usability and robustness. These models range from classic networks like MLP and RNNs to novel contributions like NBits, NHITS, TFT, and other architectures. And if you want more information, you can just check the site out over here. So now the most important thing we are going to do here is to show you how to use NeuralForecast. Now, using it is relatively simple. You should first launch an Anaconda environment, or just any Python environment. In this case, we're using Anaconda for the ability to create our own environments relatively easily. If you're on Windows, it should be fairly easy for you, and if you're on another device, you can always use the command line and look up ways to do that. What I've done here is I've created a forecaster test environment using the create button and clicked it here. And then I've run two commands. The first thing I ran was pip install NeuralForecast equals quote 1.0.0 end quote. What this does is it downloads a particular version of NeuralForecast, since the system is always being updated and might not necessarily work later. And the next thing I do is do pip install matplotlib. Matplotlib is just a system for us to graph our predictions, which is very important if you want to actually do anything useful with the predictions. So the next thing we do here is we launch a Python editor. In this case, I've launched VS Code here. Let us find a way to do something here. Now you can see our test.py, which we're using to run this. What we've done here is we have copied the code here. This is all the code over here. We've just copied it and we have pasted it into our editor. Now, before we run this, we actually need to do a couple of things. First of all, we go down to the very bottom and add a plot.show. This gets matplotlib to actually show our results. Now let's go to full screen and take a look here. And the next thing we've done here is nothing else really. We've got our stuff and we're ready to go. Now, if you want to use your own system, you should you should get rid of this here, the air passengers df, and import your own data frame. In this case, it will be a pandas data frame. The pandas data frame should contain two dimensions, such as the ds dimension here with the date series, and of course the actual data. The requirements behind it the requirements of your dataset can be seen over here on their Nixtla.io page, where your data series should be a long formatted one, where each entry has a unique ID, a date series here, which is ds, and y. Y is just a y value of the value you're predicting. ds is the date series. It's literally the date of the observation, and the unique ID is just a unique ID for each time series, which is each row. If you only have one time series, you have to include the unique ID column, which you can see here. So for example, our air passengers dataset only has two columns, timestamp and value. To use NeuralForecast, we have to include the unique ID column and rename the previous ones. And here is what their data ends up looking like. The unique ID is just a 1 for this date series, which is for, everything here really. Y is the Y value, and DS is the date stamp, date series, whatever you want to call it. So something like this should just be a acceptable data frame. Now we go over here, we set a train data frame to be a given time area. In this case, they are using everything before and on December 31, 1959 as a training data set here. And for a test data frame, it's stuff you're predicting, and they're predicting for above, for anything on or after 1960 January 1. Now this part is somewhat automatic. You just have they set a horizon here. They set models with n bits and n hits. If you want to change the model, you can presumably just change the model name here to something else, such as TFT or MLP, keeping in mind, of course, that you have to import something different. And once you're done, you run a NeuralForecast with models as models and frequency as M. Then you fit to the training data frame. You fit the models to the training data frame, and then you make predictions. And afterwards, you plot everything here. So let's just take a look at this in action. We'll hit the run button, or at least try to. We'll see that we'll see if Python decides to run today. Now, normally this should be working properly. Don't show us again. Okay, I hope this is going to work. And now you can see that the terminal's shown up. We're running this in our previous environment, as you can see over here. Now what it will do is it will train each epoch, and once it's done with training each epoch, it will run a predicting data loader here for each series. And once it's done, it should, let's see here. Okay, so let's hope this is going to work now. We have cleared the process that was taking up the terminal earlier. Now you can see that's training each epoch. It will train for 49 epochs, as you can see here, with our maxed episode 50. So we'll just go up to 49. Then once it's done, we'll run the predicting data loaders, and it will bring up the air passengers forecast. You can see this is a graph here of our monthly passengers and a timestamp. Looking at it, we have a blue line here, that's our Y. And we have the blue lines before 1959 are our training data. And now if we zoom into a rectangle here to take a look at our test data. So first of all here, this blue line, this entire blue line is the data we actually have. Everything after January 1960, marked by this line here, is our test data where we're making a prediction. The orange line is the predictions n beats makes. As you can see, it's somewhat off here. And the green is what n hits makes. So now that you know how to access and make predictions with NeuralForecast, you should be able to use the system. And thank you for watching.